Hello students, welcome back to the online lecture series of Basics of Computer Network. Myself, Assistant Professor V.R. Vadekar from Electronics and Telecommunication, Matoshi College of Engineering and Research Center, Nasik. As you are aware, we are discussing unit number 3, that is multi-access mechanism and Ethernet standard. And today we are going to see the third lecture of unit number 3. Now let's have a quick revision before starting our actual topics. Now if you remember in our previous 2 lectures, we have started our discussion with multiple access. What are the types of it? We have seen Aloha, CSMA. What is CSMA? CSMA CD, CSMA CA. In CSMA, we have discussed 3 types of methods. One persistent, non-persistent, and P-persistent. After that, we have seen CSMA CD, that is the collision detection. How CSMA CD it works when the collision it is being detected. And we understood this by means of this flow chart. Again, there is some advanced improvement in your CSMA. So we also seen another one of the type, that is CSMA CA, that is collision avoidance. By using 3 strategies as like your interframe space, your contention window, and acknowledgement. So with the help of these strategies, we avoided the collision. And we have also seen the energy level, that when the collision it is being detected, what is the energy level of the signal? How the stations would come to know whether the station it is idle, whether the stations are transmitting, or whether there is being collision detected. So just by sensing the energy level of the medium of the channel. So guys, let's start with our today's topic, that is controlled access technique. In random access, no stations, they are going to take the concern of other stations in order to transmit the frame. Everyone has the right to transmit it. But in controlled access technique, it is not so, guys. Each station, it is going to consult another stations, and other stations are giving the right, giving the permission to send the data. So that's why it is called a controlled access techniques. So in controlled access, the station, they are consult one another to find which station has the right to send the data. And a station, it can't send it unless it has been authorized by other stations. So due to this, it is called a controlled access technique. So there are 3 methods that we are going to discuss today. It is first your reservation. Second method, it is a polling. Polling means asking. And third, it is called a token passing. So now we are going to see each methods one by one. So starting with the reservation method. As you can see on the screen, that in reservation method, a station, it needs to make a reservation before sending the data. The time, it is divided into intervals, and in each interval, a reservation frame. This is the reservation frame which is going to precede the data frame sent in that interval. This is called a reservation frame. If suppose there are n stations are there, over here we have seen 4 stations, 1, 2, 3, 4. Then there are exactly n reservation mini slots in the reservation frame. And each mini slot belongs to a station. So 1, 2, 3, 4, 5. 5 slots are there. So we have considered a 5 stations. But for on this example, we have shown, 3 stations, 1, 3 and 4. But total there are what, n station, and over here n equal to 5. So you have to make a reservation for what, n mini slot. And each mini slot, it is going to belong to a particular station. So when a station needs to send a data frame, it makes a reservation in its own mini slot. See over here, which is shown in this yellow color. 5 stations, 5 mini slots are there. In the first interval, only station 1, 3 and 4, they have made a reservation. You can see it. In first reservation, station 4, station 3 and station 1, they have made a reservation. Station 2 and station 5, they have not taken participate in that one. In the second interval, only station 1 has made a reservation. See. Whereas this shaded region, it is going to tell you that only this data, now it can send the data because they have made a prior reservation. Over here, first station 1 can send, then station 3 can send, then station 4 can send because they have made a reservation. And in second time interval, only station 1 it has a data to send, so only station 1 it has been shown there. And rest they are 0, it means they are not going to take a participant in sending or transmitting your frame. And for the third interval, for the fourth interval, this process it goes on. Whenever the station they would have a data, they have to make a prior reservation for it. So it's a kind of simple method. Next, it is next method. It is called a polling access method. This polling, it is going to work with the topologies in which one device is designated as a primary station and the other devices are designated as secondary stations. So we have shown a primary station like this one, and these are the secondary stations, A and B over there. So all the data exchanges must be made, through this primary devices, even when the last destination, it is your secondary device. The primary device, it is going to control it can control the link. And the secondary devices, they just need to follow the instructions. And it is all, it depends on your primary to determine which device is allowed to use the channel at a given time. So remember, primary is always the initiator of any session. And this method, it uses a poll and select function, to prevent collision. See, this is a select and this is a poll. Methods are there. Just a major, the drawback of polling access method is that if anything happens to primary, it gets shut down. The whole system, it gets shut down. It goes down. So we can first start with this figure. See over here, this is a select function, which is used whenever the primary device, it has something to send. And it is going to control the link. And suppose if the primary is neither sending or not receiving, then the link is idle, the link is available. But if it has a something to send, then the primary device it sends it. But this primary device, it doesn't know whether this receiver station B over here, whether it has prepared or not. Whether the target device is ready to accept, is ready to receive. So that's why those primary, must alert the secondary to the upcoming transmission and wait for the acknowledgement. So that's why we have used a select function over here. So that this target device, this destination, it gets alert. And if it is ready to receive, then it is going to second the acknowledgement. Positive acknowledgement, yes, I am ready to receive the data. Then after this one, it is going to send the data frame, and then this data frame, it has been reached to the, the target device. And after receiving the data, it sends the positive acknowledgement. Yes, I received the data. So this is about your select function. Now this is called a polling method. Polling in the sense it means asking. It means it is going to ask these devices whether you have a data to send. So suppose when this device A first, it is being approached, it responds with this NAC frame. See, the primary device first is asked, it sends a poll frame to this device A, first secondary device, and it responds with a NAC frame that it has nothing, to send. So that's why if it is nothing, then it is going to, the response, it is a NAC frame, that is a negative frame. Then after that, this primary device, it is going to ask, it is going to poll another station. So whether you have a data to send, then if station B, if this device, it has a data, then it can send its data. And when the data, it has been received by this primary, it is going to read the data, and then it is going to send an positive acknowledgement verifying it's received that yes, I got your data from station B to this primary. So in this manner, this polling method, it is going to operate. So it is a quite simple, guys. Just two methods, select first, and second method, it is called a polling method, asking. Now, next it is called a token passing access method. It is quite one of the important method. You can see from this figure, the stations, in a network are organized in a logical ring. See this logical ring. Each station, for each station, there is a predecessor, there is a successor. For station 1, 4 it is a predecessor, and 2 it is a successor. Similarly for 2, 1 it is a predecessor, and 3 it is a successor. Predecessor in the sense which is logically before the station in the ring, and successor in the sense the station which is after the station in the ring. Now, accessing the channel now. How to access the channel? This is the question. Who would be given the right? So, the right to this access, it has been passed from the predecessor to the current station. That is 4 to 1, or 1 to 2, or 2 to 3, or 3 to 4 like this one. And the right, it has been passed to this successor when this current station, suppose station 1, it doesn't have any data, no more data to send, then it is going to send the write to this station 2. So in this, guys, why this name token it has been given? Because how we came to know the right to access the channel, it has passed from this one station to another. So in this method, guys, a special packet which is called a token, it is going to circulate through this ring. And the position of this token, it gives the station the right to access the channel and send its data. If station 1 it has a token, then now station 1 has the right to send the data. If station 1 it finish its the data transmission, it forwards that token to station 2, and if it has a data, it is going to transmit the frames data. Otherwise, it is going to pass that token to this next station, and this process, it continuously, it happens in the form of your ring. So that's why, the ring, it has been shown like this one. Although, the topologies, it could be different, guys. But although it is appearing a physical ring, but over here it is a bus topology, it is there, star topology, it is there. But they are working logically in the form of your ring fashion. And this token management unit is very needed for this access method. The station must be limited in the time, they can have a position of the token. It doesn't mean if station 1 has the token and it has going to transmit the frame for a continuously whole day, it should not happen. So some limit it has been given to each station for during that particular time they can keep the token, and after that at any cost they need to circulate this token. Because token, it is going to assign the priorities to the station, to the types of the data being transmitted. Token also, tell it is a low priority station or it is a high priority station. So token, it should not be lost or destroyed. Otherwise, it may happen the token would, disappear from the network. So it is very important to keep this special packet, this token, alive. So as from this figure, now you can see this. Although the stations don't have a physically connected in a ring, you can see this is a bus topology. But this ring is a logical topology, it is a physical over here. So in bus ring topology, which is also called as a token bus, the stations are connected to a single cable. See, it is a bus. And however, make a logical ring because each station knows the address of its successor. When a station had finished sending its data, it releases the token. And inserts the address of its successor in the token. Suppose station 1 it is there and it has finished the data. Now it is going to pass the token to this station 2. And in that token it has the address of station 2. And only the station with the address matching. Then the destination, the address of the token gets the token to access the shared data. If this destination address and the token address, if it is same, then only then the station 2, it has access to that shared media. And similarly, you can see it over here. This is a star ring topology. Although the physical topology, it is a star because they are connected to a single hub, central hub, just which acts as a connector. So with the wiring inside this hub, it makes a ring like this one, and the stations are connected to this ring through this 2-wire connection. See this, each station it is being connected to this hub through this two wire connections. Because due to which, it gives what? It makes the station network, less prone to failure, because any of the link it goes down, it will be bypass this, by the hub, and the rest of the stations can approach. See, anything happens to station 1, so it is going to, bypass the station 1, and it is going to transmit the data to this one, 2, 3, 4. So entire station, it is not going to collapse, although which happens in this physical ring topology. And also, the addition and the removal of the station from this ring, it is also easier. And this is called a dual ring. It uses, see, it is shown in the pink color, which is nothing but your auxiliary ring, which operates in the reverse direction compared with this main ring. This main ring, it is operating in the clockwise direction, whereas this auxiliary ring, it is operates in what? Anti-clockwise direction. If anything happens to this main ring, it fails. The system automatically, combines these two rings to form a temporary ring. And after this main link, it is being restored, then the auxiliary ring, it becomes idle again. So we are going to use this auxiliary ring for a temporary purpose. And remember, in order to work, in order this topology to work, each station needs to have a 2 transmitter ports and 2 receiver ports. Then only then this dual ring, it would apply. Basically your fiber distributed that network and copper distributed network, they are going to use this dual ring topology. So guys, we have studied the 3 methods of controlled access technique. That is, first we studied about reservation. In reservation, those stations, those have a data, they have to make a prior reservation. By sending the reserve frame, they have to reserve themselves. So number of slots, it is going to denote the number of stations. After reservation, we have seen polling method by using select function and poll function. So in first select function, it is going to, alert the target device that I have data, I have to send it, so be prepared. And if it gets ready, it sends a positive acknowledgement, otherwise it sends negative acknowledgement. And then it is going to start the transmission. But in second, we see in polling function, it is going to ask secondary stations whether you have a data to send. So if yes, they are going to send the positive acknowledgement, and then it is going to send the data. Otherwise, stations, secondary station, those who don't have a data, they are going to send the NAC frame. And in third frame, in third method, we discuss about this token ring concept, a special type of packet which is being circulated in a ring. That could be your physical ring or that could be your logical ring, although the topology may be different. But logically, they are connected in a ring fashion. So those who would have that special packet token and the address of the station, address of the token it is going to match, then that particular station would have the access onto that shared media. And once the transmission it is being over, it is, passed that token to its successor. And this process, it goes on. So this is a third assignment of unit 3. So please note down these assignments. In next module, we are going to discuss about the channelization that is used in cellular telephony, that is your FDMA, frequency division multiplexes, TDMA, time division multiplexes, and your code division multiplexes. So thank you very much, students, for today's lecture. Thank you very much.